Let's create the first microservice. A new project. We'll call it Payment Microservice. We choose Maven. Here I will name Kafka Demo. The package name should be named and consistent in both microservices. Later, I will explain why. Spring Web. First, let's go to the POM file. What else do we need here besides the Spring Boot starter? I'll copy it directly from my notebook. We need Lombok and Kafka. Kafka, Spring Kafka. Up to this point, Spring Kafka is essential for working with Kafka and usually Lombok. Next, we go to Application Properties, and here we write down the following. Server port, server port, server point port, 1880. Next, we write, since this microservice will be a producer, we write screen card producer. And here we need to specify the card servers, but it is not necessary to include all of them. We can specify 1, we can specify 2, we can specify 3, because they all see each other. We will specify 2. 2, well, how will it turn out? Well, post 90, 90. Well, let's do 94. Next, we will specify the serializer for the key. I already mentioned that messages in Kafka contain keys and values. And for them, it is necessary to specify the class that will handle serialization, because Kafka stores the message in the form of bytecode. Therefore, a serializer is needed for the producer, and for the consumer, a deserializer will be required. They can be specified separately. A serializer of one type for the key, and a serializer of another type for the values. Someone understood this?
Yes, we will show you. We haven't left here. If we have them, the servers, if, for example, well, as if they are deployed locally, then yes, they can all see it. But if they are deployed in different locations, will they still somehow be able to see it?
I think so, because their properties contain each other's data. We specified that there is a parameter there where we listed them all in each file using X in the first, second, and third.
So if I understand correctly, we need to run them simultaneously so that they can see each other, right?
Yes, but if it's not strictly necessary for them to be running at the same time, they will just attempt to connect if they don't see each other immediately.
I think this will be a separate topic for our video, where we will try to set everything up on a remote server, launch it all, and see how it works there.
That is, our viewers write in the comments if they want to see it.
Subtitle editor iBoykova. Let's gather 1,000 likes.
Yes, let's do it this way. 100 likes and we'll show how to run all of this on separate servers.
So we specify the serializer for inclusion, Spring, screen card producer, and serializer. Here we write org.apache.kafka.common serialization string serializer. We set the serializer value serializer.json. Here we will select from options like JSON, Spring Framework, Kafka, Support, Serializer, Kizil, Serializer. That's it. Next we will specify Spring Kafka in our project. I don't know what all the laser is exactly about, producer asks. This parameter indicates how many brokers we should wait for a response from when sending messages. We can write here all from everyone from 1 or specify a specific number from 2, 3, 4. Next, let's move on. Now we will create a config. And inside Kafka config java class.config, it is stated that this is a configuration. This annotation indicates that the class is a configuration class and is used to define the length of the Spring context. Here, we will add the environment field. We need it because it is necessary and important so that we can extract different variables from our application properties file. Here, we will write AutoWire. Next, we will write a method that returns a map with values string.config, string.map. Next, we take this map.config and simply add variables from our application.process file. In principle, this could have been avoided. We didn't necessarily need to create this configuration file. However, it is created using Java, which allows us to add different conditions, not just to take variables, but also to set different conditions, one under certain circumstances, another under different circumstances. First, we will place them here and take them from the environment variables using environment getProperties and copy them further. Environment.getProperties is a method that environment.getProperties producer.config.value is used to producer.config.value serializer.class.config.environment. GetProperties is another method that serializer.class.config.environment. GetProperties. This method, which is part of the Kafka producer configuration, creates and returns a field with the necessary configuration settings. This method creates and returns a field with the configuration of the Kafka producer. Next, we will create a bin that will configure the Spring container. It will create and set up the producer factory. The producer factory is responsible for creating the Kafka producer. So, the bin, it is responsible for creating both producers, and it is unlikely that the bin will work. And here we specify the format in which we will send the key and value as a string. The key is sent as a string. The value we will have, since this is our payment microservice, will be the payment created event, which we will create now, a little later. What class? Specifically payment created event. It seems there are no errors. Well, like the producer or the Kafka producer, it's like, something's not quite right. But everything seems to be okay now. It doesn't complain anymore. Yes, that's right. Next, we need to create a bin Kafka template. This bin Kafka template is necessary for sending messages. It is used in the producer factory. We will also create another bin that will create the topic for us. He talks about what year it is, and as he says, I don't understand what he's saying. Come on, he says, you think about nothing. On it, how does he know? Well, now, in this factor, or another day, we will create what creates the topic. For me, don't drown the topic. So, what are you doing? You did it, right? Here we need to set the name of the topic. Well, the topic will come with the name. The topic name is usually written. Next, then we specify the number of partitions that we want to have in our topic. We will set the partition to 3 and the replica to 3 as well because we have 3 brokers. Replicas refer to the number of copies. The number of copies does not mean that the number of replicas equals the number of brokers. We can have 10 brokers but only 3 replicas. This is because there can also be many topics, and this topic should be repeated 3 times on 3 brokers. We will create another topic. It will only have, for example, 3 replicas but already on different brokers. It's clear, right? Next, we will specify and add another configuration. Map point of Mininsing triplicas 2. This parameter indicates the minimum number of replicas from which we must receive a response when sending a message. By response, I mean the response that the producer receives back from Kafka, a response indicating whether the message was sent successfully or unsuccessfully, and we write the build. So, that's it. Next, we will first create the ritual. First, we will create a DTO that we will later process receive an event and send. So, in the DTO, we will create a DTO package. In the DTO, we will create a class. Let's call it DTO. We will add the data annotation. Here we will have 4 fields. Private bit data, some string created at, if you have a question, why string, because local datetime has issues with deserialization. Private string ordered and private string user-id, which are essential for processing, are the minimal set of fields for a payment. This is the amount when it was created, the payment that was made, what the order was, and whose payment it is. Now we will create payment created event. It will contain all the same fields plus 1 additional field. Thus, we will create a folder named event, and within it, a Java class called payment. In it, the wife will understand the prement, ement. Here we will add data and another argument. all arguments and no arguments. Here we will copy all fields from the DDoS, and there will also be a private string, and step back. Okay, now let's see if I can sneak in a class there. So, let's go ahead and import the necessary modules and libraries that we will need for this project. Okay, good. Now, the next step is to create the controller. To do this, we will use the tab key to navigate and create a new controller. This controller will be responsible for managing the flow of data and handling user interactions. Let's proceed with setting up the controller. We are writing the method public response entity. I write response entity because it can return different objects. Only string. I'll write string, create, request body, nmd2. This will just be mapping for us. More or less, this is exactly for that. Specifically for chemistry. It will just be mapping. I can't. We are writing? Oh, not here. String. We will simply return payment ID. Payment ID equals payment.service, which we do not have yet. Payment service.create. Now we will create all of this. We will pass payment.d2. We will return response entity, HTTP status.created, payment ID. So, in order to proceed, we need to utilize the payment service. Here is an example of how to use it. Private, payment service, auto-wired. This is crucial for our implementation. All right, let's move forward with this setup to ensure everything works correctly. Now we are creating payment service. We are creating package service. First, we create the payment service interface. Here we add the string create method, which will accept the complete BTO. What problem do we have here? Let's now create the implementation of this interface currently. First, create a folder named info and inside it a Java class that we will name the service, and it's a service. Okay. And now we need to implement this create method. We need the amplification of the service here. So let's get started. We don't have a database here where we will store our DTO. We will assume that we have it simply because we currently do not have the goal of showing how we interact with the database. I will just randomly generate it, as if we saved it and returned the payment ID. Let's write it like this. The payment ID is set to the value of unit.rentalunit.toString. Next, the payment.createEvent method is called to create the event in the system. Basically, we create the event that we need to send it to Kafka. New payment, created event. Essentially, we create the necessary event to send it to Kafka. New payment, created event. And here, with a constructor with all the arguments, we place them payment ID, payment get some, payment get created, payment get ordered, payment get user id. Next, we proceed to create such an object, which will be completed in the future. This object is called completed.future. This class represents the result of a send operation that can be completed successfully. It provides information about the status and outcome of the send operation. The send result method is fundamentally the procedure used for transmitting a message. This method is crucial in ensuring that the message is properly sent and received, playing a vital role in the communication process. So the key is string, and value implement is equal to the figure of the key. I don't have anything here exactly. Kafka template. Here we need to initialize the Kafka template variable, Kafka template.send. That's it. And here we see that the send method is overloaded. Here, you can specify a different number of arguments. We will specify 3 here, which consists of a topic, a key, and a destination. So we simply send to the topic that was created earlier. Next, we specify the key. A key can be specified or not specified. If we do not specify a key, our message will go to a random partition. If we specify it, then the first time it will also go to a random partition, but with subsequent message sends using the same key, it will go to the same partition as the previous messages, to the same one. I will specify paymented and payment created event as the key. Next. This class compilable future is used in Java for asynchronous computations. When we use this class, it means that our adapter operates in asynchronous mode. It is precisely at this point in sending a message to the topic. Next, when complete. When complete is a method of completable function that registers an action to be performed after the completion of an asynchronous operation. It takes two parameters, result and accept. That is, if it executes successfully, it will return the result. If not, it will definitely return an exception result. If everything went well, meaning the exception is not equal to 0, we will simply print it out. Wait, if it is not equal to 0, then there is indeed an exception, which means that not everything is fine. Failed message with the text of this exception. Otherwise, we send a message was sent successfully, plus result, get record metadata. And from here you can take the topic, what was returned, get the offset, get the timestamp. We will simply write to string. From here we can take the topic, the one that returned, take the offset, the timestamp. We will just take it. Write it as a string. Yes. In the end, we will also display the ID. This is to see the order in which we will receive the consoles and messages. Modi, ASU, plus pmodi. And let's return pmodally in a manner that is more appropriate, fitting, and suitable. So, I have now shown you the service method that sends a message to Kafka in asynchronous mode. What does it mean to operate in asynchronous mode? It means that our producer sends a message and does not wait for a response from Kafka, but immediately sends the next, and so on. The responses from Kafka are processed later. This class is responsible for the asynchronous mode, completable future, and when complete. When we have these two words, it means that Kafka operates in asynchronous mode. In general, we typically need asynchronous mode when the sent communications are generally not of great importance. For example, when some GPS coordinates are sent, they are constantly being transmitted. It is not very important to us that everyone must reach GSET. I will try to send it now. We currently have an improvement in this producer. Get a response. Here we already have a prepared JSON sent. There. Now everything worked out. Here is what needed to be proven. Look, first we obtained the payment ID for our service. First, we got this. What was written at the end of payment ed, and only then did we receive a response from Kafka. The message is sent successfully, and here is its result, get record metadata, in such a strange form, but we still got it. This means that Kafka is working in asynchronous mode. Now I can show how to modify this method so that it works in synchronous mode. This means that Kafka sends a message, waits for a response, and only then can send the next message. The advantage of this method compared to asynchronous ones is that we have guarantees that our message will be sent. However, the downside is, of course, speed. The synchronous mode is slower but more reliable. So, to switch to synchronous mode, we need to remove compatible future. We simply insert send result, and here we will simply create the result. Kafka template send, it's all basically the same, but at the end we also add get. This get right here, this is the key moment, where it tells us that we receive a response and do not move forward until we get that response. It is highlighted in red because it throws an exception from this method. We will definitely add it to the method exception signature. That is, we have added it here and in the interface. Next. We no longer need when complete. Now we simply write, so, I'll just remove all of this. So, we are waiting for the result, and now we will display this result on the screen. Last time we simply took get metadata, but now we will take different data from this metadata and pull it. For example, we will take topic plus result. Get record metadata. Get topic or topic. Results get record metadata dot get topic. Then we will ask him to print the partition where it is being recorded in the system and verify the details thoroughly and completely. And in the end, we will leave 5. We will ask to print its PMID. Let's see how it will be printed now. Well, you guessed it. Everything will be printed out first and only then the PMID. So we have exceptions here now. And accordingly, we need to handle them in the controller. We have 2 different exceptions here, but I will make one. If we encounter an exception, I understand that we have 2 different ways to react. I will just make one exception. If we choose to handle it with an exception, so we will return. I am creating it in the controller. There will be 2 fields, data and string message. Here we write new. Internet server, February point. Will I have probably message just a minute. Date. I created it in the controller. There will be 2 fields, data and string message. So here we write new date, and there are 5 months, data and string message. So it highlights for us because we are returning a string. Here is a string and here is not a string, so we write objects. Here, now, everything is fine. In case of an exception being thrown, we will return an error message. If everything is fine, we will return a string. So here we set it to O. That's it. We launch the microservice. If everything goes well, we will see 4 messages in the console, followed by a 5th message with the payment ID. Thus, the service is running. The microservice is up and running. We are sending the DTO. Everything is fine. The topic has been routed to the second partition. An event has been recorded, offset 0. This means that from the very beginning we have the timestamp and paymented at the very end. Good, excellent. Let's try again, just to see which partitions are being written. The next message, also partition 0. The first time it was partition 2. Now it's partition 0. It's being written again to the 0 partition. Here we already have offset 1. Do you remember what offset is? Offset is simply a shift because there was already one message in partition 0 and this is the second one. So, offset 1. Then the next one was recorded in partition 1, offset 0, and in partition 2, offset 1. It's clear, right? By the way, I discovered the Kafka plugin today. I accidentally installed it. Well, not accidentally, I installed it in VGA in the Kafka plugin. And it's quite interesting. Look here, right over here, you can see how many messages we have recorded in each partition. Here is the message count, where it starts from which offset, and where the offset is currently located. This is our leader, the leader in this partition. For example, in the 0 partition, the leader is the 3rd broker, while the 1st and 2nd brokers are followers. For the 1st partition, the leader is the 1st broker. And for the 2nd partition, the leader is the 2nd broker, while the others simply duplicate it. Here we can also start the producer and send a message directly from here. Let's try it. The topic is correct. The key is of type string. The value is of type JSON. We insert this JSON here and send the produce. So, here we have the consumer opening, start consuming, start consuming. Now let me try to send, and here you can see that the consumer received the timestamp. Here, the timestamp is displayed well, key, value, and here is just the timestamp that Kafka itself creates. And here, inside is the timestamp, and this one won't be very pretty. Well, in this object. Well, in general, it's not mandatory to use this, but it's just a rather curious thing. For example, when you write to the producer in the microservice and you don't have a consumer yet, but you still have a lot to write there, you can easily check whether the messages are being sent or not. Look, the consumer has read it. Now let's move on to creating the consumer. This will be our microservice. Certification. Let's create a new project. Let's just call it certification. Oh, I just wanted to show it there. Microservice. Microservice. And here I will change package name to Kafka demo in this example. so that they are the same for both microservices. I will explain later why this is necessary. Maven, Angela, Maven, so. Next, here we can select Lombok, Spring Web, Spring for Kafka. Hello, new window. So, the first thing we will do here is check the POM file. We have all the dependencies in place here. Spring Boot Starter, Spring Kafka, Spring Boot Starter Test, and Spring Kafka Test. That's enough for now. Now let's go to Application Properties and configure it. The Spring Kafka Test is sufficient for now. Now let's go to the ropers and set it up. Let's write down the properties for the Kafka consumer here. So the first thing we will write is the server port. Server port. Port equals 8080. We cannot use it because it is already occupied by the producer, 8081. Next, Spring Kafka, consumer bootstrap servers. Spring Kafka, and here we specify our brokers. You can specify one or several, or all of them. I will specify 2. Next, we will specify the serializer for the key. In the producer, we specified the serializer. In the consumer, we specify the deserializer. It's strange that it doesn't provide suggestions. Yes, it's unfortunate that it doesn't provide hints. It's easy to make a mistake here, of course. Next, we specify 10 realizers for the value. The next thing we will specify is the consumer group. This must be specified if we have. It doesn't matter how many consumers we have, whether one or several, we need to specify the consumer groups that they all belong to. And we will also specify the trusted packages. For now, I will specify everything. And we will also specify trusted packages, as per the end. Turn off. The native one I still seem like this. I will fix it later. I hope I don't forget. So, that's all for now. Next, let's create a directory config. Oh, not here. So here we will create a class. So, I probably wrote it incorrectly here. Let me explain a bit more about this. Spring Kafka Consumer Bootstrap Servers. Correct. Bootstrap servers. Well, okay. Alright. Let's create the configuration here now. Here we need the environment. Inject it immediately right away so that we can access the environment variables and settings. Now we will write a method that creates and configures the consumer factory. The consumer factory is used to create Kafka consumers. This will be a bean. I have a stake, cloud. Why is it like that? First, we will create a map, which contains all the necessary properties that are required and essential for the functionality. String object, object.config.new hashmap. And here we need to place the properties that we specified in application. Properties.config.code, consumer.config.obstruct.servers config. We simply take from environment get property and specify this in quotes.
Chalva.
Next, config pod key. Here is the implementation for the key, consumer config. Here is the implementation for class config. Next, we will place another one here. This is the implementation for value. Get property, 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 get proper returning, new. Here is such an object. Default Kafka consumer factory, which takes the configuration. Based on this configuration, it creates consumers. Next, we need another bean that will create a concurrent Kafka listener container factory, which is used to manage Kafka listener containers. In other words, we need to create not just a listener, but also place it in a container. It manages the operation of the listener, concurrent Kafka listener container factory string, object. Kafka listener container factory takes consumer factory as a parameter. We create an object with such a long name string. Thus, in each parameter, it takes the consumer factory. I won't bring you the swing. Object. We definitely give an object with such a time name. In this step, we are going to set up the container factory, which is a crucial part of our configuration process. This will ensure that our containers are properly managed and initialized. Return the consumer factory instance that is responsible for creating and managing consumer objects. Now our configuration is complete. Next, we will create an event handler that will listen to the Kafka broker. New package handler. Here we will create a class. So, this one, here is just one class. Right, let's add the component annotation. And we write this public void method. It will listen to such events. For example, hello Ivan. Payment microservice will understand. Hello Ivan. Payment created event. It is not found yet because it is not here. That's understandable. We need to create such a pass. We will do that now. And we will simply output it to the console. Event received. Effect, and we will output it to string, so this will be ours, to string, so this will be ours, to string, so this will be ours. You need to add an annotation like a listener, and in parentheses, we write which topic it will be listening to. Topic name, so, topic, topics, well, pain, no. Topics, payment, created event topic. So I will copy it from here. Payment, created event topic. Ctrl-C, Ctrl-V. Now, this is the topic. Yes, it is now available. We need to create a class like this in the payment microservice because it won't understand it. We don't have it here, and it won't recognize it. We will simply copy it from the payment microservice. Copy, paste. So, for what purpose? This is why we needed the package with the same name Kafka Demo. Here is Kafka Demo, and there is Kafka Demo. Because you see, the payment created event is indeed actually in fact in this folder. If it were in a different folder in this project, it would not be able to be implemented here. In that case, it would be as if it were not the same object, but a different one. Importing the class. So why doesn't toString want to see? They should have toString, right? Payment created event. That's it, toString. That's basically everything. We can try to receive a message, but there is one more nuance that needs to be taken into account. If for some reason we are unable to obtain this object, this event, then this microservice will endlessly attempt to retrieve it, and thus this microservice will fail. It will not continue to operate. It will not skip it. Nothing will happen. Even if we restart it, it will still try to read the unread messages from the broker. Therefore, we need to account for the exception. Disrealization exception. It will be specified here in the Kafka configuration. Instead of this value disrealizer class config, we will write this to explain the process in detail. Now, just a moment, step by step, carefully. Error handling disrealizer class.class. Now we will test it thoroughly. Let's run it and ensure everything is clear. Alright, here we have it running and we are sending so that there are no misunderstandings and all steps are followed correctly. And let's see what we have there in the console. Here we received it. Event received. And here we have our payment received event with all the data. This is basically everything I wanted to show. How to send messages between microservices using Kafka. You can write questions or suggestions about what else you would like to see on this topic. For example, how to run Kafka in Docker or in the cloud. Right.
Anything related to the features of Java.